Hello viewers, in this video I would like to discuss CS Main 2011 question number 1D of Operations Research. This is from paper 2 Mathematics. The problem is solved by Simplex method. The following problem, this is LP problem, linear programming problem, and it is maximize z is equal to 5x1 plus 3x2 and constraints are 3x1 plus 5x2 is less than equal to 15, 5x1 plus 2x2 is less than equal to 10. So x1 x2 are greater than equal to 0. This question is of 15 marks. So first we write the problem in standard form. So given linear programming problem, we are writing in standard form by adding slack variables, because both of the constraints are having less than equal to sign. So we will be adding slack variables, means something is less on left hand side. So we rewrite it, maximize z is equal to 5x1 plus 3x2 plus 0s1 plus 0s2. I will come back to this again. Subject to this first constraint is 3x1 plus 5x2 plus s1 is slack variable is equal to 15, and 5x1 plus 2x2 plus s2, this is again slack variable, is equal to 10. So in objective function we write 0s1 plus 0s2. So now four variables are there, x1, x2, s1, s2, these are greater than equal to 0. We rewrite the objective function in the equation form and we bring these two on left hand side. So this becomes z minus 5x1 minus 3x2. We solve the problem by -0s1 Simplex method. We write down the problem in tabular form and we call it iteration 1, in which s1 s2 are basic variables and value of s1 is 15, value of s2 is 10. Non-basic variables are x1 x2, which we have taken 0. In this table we are writing z, x1 x2 s1 s2 and solution. Z row shows the coefficients of z equation, which we have written in the previous slide. So coefficient of z is 1, coefficient of x1 is -5, coefficient of x2 is -3, s1 is 0, s2 is 0 and solution is 0. And s1 row shows the first constraint in which slack variable s1 is coming into picture, and we have written coefficients of z, x1, x2, s1 and s2, which are 0, 3, 5, 1, 0 respectively. Similarly, we have written the s2 row in which we have written coefficients of second constraint where slack variable s2 is coming into the picture. So after doing this, we got this first table, starting table, which we have called iteration 1. We find out most negative value in z row, because this is the maximization problem and we have to find out most negative. So coefficient of x1 is -5, which is most negative. We got the pivot column. This column is pivot column. Now for finding the leaving variable, we use the elements of solution column and divide elements of solution column by corresponding elements of pivot column. So we get the ratio as 5 and 2. 2 is minimum. So corresponding variable s2 is the leaving variable. Now for further calculation, we do these calculations with the help of these formulas. So s2 row, which is the pivot row, now we divide it by 5, that is the pivot element, and we divide this row by 5, so we get the new s2 row, and in next table we replace s2 by x1. For writing s1 row and z row, we use these two formulas. So new s1 row is s1 row minus 3 new s2 row, and new z row is equal to z row plus 5 new s2 row. So we got this table. Let's do one example here for calculating the elements of this table. Let's see this -1, and we got -1. How? So this is z row. So new z row value is -1. How we have got it? So z row was earlier corresponding to x2 was minus 3. So minus 3 plus 5 into new s2 row. New s2 row is 2 upon 5. So it means minus 3 plus 5 into 2 upon 5, which becomes minus 3 plus 2, which is equal to minus 1. Similarly, for each element we will be doing this type of calculation, and we got this one. We see, check the z row again, and we see minus 1 is still there, negative element is still there. It means we have to do some further calculations. So coefficient of x2 is most negative. It means this is our pivot column. Now we find out ratio with the help of solution column, and each element of solution column we divide by corresponding elements of pivot column. So we got this 45 upon 19 and this 5. So this is the minimum one, and we got s1 as leaving variable, and 19 upon 5 is our pivot element. So we divide s1 row by 19 upon 5, and with this new s1 row, x2 will enter, s1 will leave. So in next table we will write here x2, and with this new row we will be changing our z row and x1 row by the following formulas. We write the next table with the help of these formulas, and these are x1 row is x1 row minus 2 upon 5 into new s1 row, and new z row is equal to z row plus 1 new s1 row. So we got this table after doing calculation as we did in previous one element calculation we have done. So we got this table, and in z row we check there is no negative element. It means we have reached to our optimal solution, and optimal solution gives us values as x1 is 20 upon 9, x2 is 45 upon 19, x1 is 20 upon 19, x2 is 45 upon 19, and z value is 235 upon 19. So we got our solution, and objective function value is maximum, which is 235 upon 19. Thank you. Hello viewers. This is a question of CSE in 2017 Mathematics Paper 2 of Operations Research. Question number 3C, Simplex method. Question is maximization z is equal to 3x1 plus 5x2 plus 4x3. It's a linear programming problem, and we have to solve it by Simplex method. The constraints are of less than equal to sign, and all the variables are positive. This is a question of 20 marks. So first we do the standard form of this problem. So we write down it in the equation form. Maximize z is equal to 3x1 plus 5x2 plus 4x3, and here we can see the constraint is less than equal to sign. So we add slack variable here. So s1 is slack variable in first constraint. So similarly we can write down slack variables in second and third also, which is s2 and s3, and all the variables x1, x2, x3, s1, s2, s3 are greater than equal to 0. In the objective function we can write down 0 s1 plus 0 s2 plus 0 s3 here. Now what we do, we take all the terms on right hand side to left hand side. So z is equal to minus 3x1 minus 5x2 minus 4x3 is equal to 0. Now we write down this starting table, and this is having basic variables s1, s2, s3, and this row shows the z row. So here we have written coefficient of z, coefficient of x1, coefficient of x2, coefficient of x3, coefficients of s1, s2, s3 respectively, and this is right hand side. So we see once we had written all the coefficients, all the variables on left hand side of objective function. So this becomes 1, minus 3, minus 5, minus 4, 0, 0, 0, and right hand side is 0. Similarly we can write down all the coefficients of s1 row here, all the coefficients of s2 row here, all the coefficients of s3 row here, and these are the right hand side values. Now we see which one is the most negative. -5 is most negative, so this becomes entering variable, and corresponding column becomes pivot column. And now we have to find out which one is the leaving variable. We find out ratio, and ratio, how do we find out? We divide solution by the corresponding element of pivot column. So 8/3, this is 10/0, which becomes infinity, which we have to ignore. And if it is negative, then also we ignore infinity, and negative values we ignore. And next is 15/2, which gives us some value. So we see 8/3 is the minimum value, so corresponding variable S1 becomes leaving variable, and the intersecting point of entering variable and leaving variable becomes pivot point, pivot element. Now we need to do some further calculation, but this calculation I have shown again in this table. This is basic variable, entering variable, solution, and here we are finding ratios, and this one is the minimum. Now for further calculations we need Gauss-Jordan. So next table we can write down with the help of above formulas, and here we see Z is same, S1 has been replaced by X2 because it has entered, S2, S3 are there, and we can write down calculations for X1. This is the calculation for X1 by using the formula, calculation for X2 by using the formula, and here also. So we get these values: 1, 1/3, 0, -4, 5/3, 0, 0, and 40/3. Similarly we can do for all. Here for pivot we did that, we have divided by pivot element, and with the help of this we have done this calculation with the help. So in a sense we can say first we did the pivot row calculation, not Z1. First pivot row, we have divided pivot row by pivot element, and then with the help of these elements we have done this calculation, and with the help of this, with the help of this. So again we have to see which is most negative. So -4 is the most negative, so this becomes entering variable, and this becomes pivot column. We have to find out the leaving variable. For that we find out the ratio. So 8/3/0 becomes infinity, 10/5 is 2, 29/3 divided by 4 is 2.4. So minimum value is this, therefore S2 becomes leaving variable. And we further do some calculation according to Gauss-Jordan formula, and we do that X3 has entered, S2 has left from here. We divide this row with the pivot element, and with the help of this row we calculate rest of the rows, and once we calculate we get all the elements in the table, and we see Z row there is no element or coefficient of variable X1, X2, X3, S1, S2 is negative. It means we have reached to our optimal solution, and optimal solution is 64/3. And here we can write down the solution that X1 is 0, X2 is 8/3, X3 is 2, and Z is equal to 64/3. We can see this in table again, that X3 is 2, X2 is 8/3, X1 is not existing in the solution, and this is the solution 64/3. This is what we have written here. Thank you. Hello viewers, this is CS Main 2016 Mathematics Paper 2, question number 2C of Operations Research, and question is of maximization type. Maximize Z is equal to 2x1 plus 3x2 plus 6x3. This is the objective function, and these two are the constraints which are of less than equal to type, and what is given here that all the variables are greater than equal to 0. So we can solve this problem by the help of simplex method, and further we have to find out is the optimal solution unique and justify your answer. This question is of 20 marks. Now we can see that this question can be solved by simplex method, so we need to write down this question in the standard equation form, and this is the standard equation form where we make constraints as equal to sign after adding the slack variables in the constraints. S1, S2 are the slack variables. So we write down the objective function like maximize z is equal to 2x1 plus 3x2 plus 6x3 plus 0s1 plus 0s2, and subject to the constraints are 2x1 plus x2 plus x3 plus s1 is equal to 5. Similarly, we can write down second one, and all the variables are greater than equal to 0. Before going to tabular form of simplex method, we need to know Gauss-Jordan formula, and these are the Gauss-Jordan formulas. New pivot row is equal to current pivot row upon pivot element, and these the second formula is for all except the pivot row, means for z row as well as other basic variables. So we write down the table for starting table. We write down basic variables here s1, s2, and z row is we have written after taking all the elements to left hand side. So coefficient of z is 1, coefficient of x1 minus 2, coefficient of x2 is minus 3, coefficient of x3 minus 6, and coefficient of s1, s2 are 0, 0, and solution is 0. Similarly, we can write down the s1, s2 row, and these are the right hand sides of s1, s2. Now what we do, we see which one is the most negative in z row. So minus 6 is most negative. This x3 becomes the entering variable, and this column becomes the pivot column. For finding the leaving variable, we have to divide the solution by the pivot column elements, corresponding pivot column elements. So 5 upon 1 is 5, 6 upon 2 is 3, and we select minimum value. 3 is the minimum value. If we get in any case negative value or infinity, we will ignore them. So corresponding to 3, the leaving variable becomes s2. So in next table we see that x2 has left from here and x3 has entered, and what we do, we divide this row by pivot element, that is by 2, and after getting this new row we change the z row and s1 row by using the Gauss-Jordan formula, and after writing all the elements we see again in the z row, is there any negative elements? Yes, minus 2 is the negative element, so this is the entering variable, and now x1 has become entering variable, and this column is the pivot column. So now by writing ratio, that is we divide the solution elements by the pivot column elements, and we get 1 and infinity. We ignore this infinity, and to see the leaving variable corresponding to 1 we get s1, and s1 is the leaving variable. So now we take next table, and here we say x1 has entered and s1 has left. Again we do the same calculation, that we divide the s1 row by the pivot element and get x1 row, and we have written this x1 row. With the help of x1 row we will write z row and x3 row by using the Gauss-Jordan formula, and we get all these values for z, 1, 0, 7.5, 1, 0, 1.5, and solution is 20. Again we see is there any negative value, because it is a maximization problem. So we see there is no negative element in the z row. It means we have reached to optimal solution, and our optimal solution is 20, and corresponding values of variables are x1 is 1, which is 1, x3 is 3, and there is no x2 in the solution, so we write down x2 as 0. And if we change the solution, then it won't be optimal. Therefore this solution is unique solution, because if x2 will enter, then it will change the solution, which won't be optimal. Thank you.